Day 35, specific heat. The specific heat of material is the amount of energy required to raise the temperature of 1 gram of a material by 1 degree Celsius. Let's look at a couple problems. And what we have here, it says determine the amount of energy required to raise the temperature of 100 grams of water from 25 degrees Celsius to 70 degrees Celsius. So we have our recipe. Delta Q equals MC delta T. Delta Q is the energy change. How much energy does it take to change this much mass of this material by this much temperature? Delta T. Delta Q equals MC delta T. Now, some of you may still be uncomfortable by saying the word delta. You may be unsure what this means. A delta T is nothing more than a final temperature minus an initial temperature. A final minus an initial. And so this delta T is nothing more than a change in temperature. So a delta Q would be a change in energy. So a delta Q would be a final energy minus an initial energy. Okay, let's go back to the problem. Determine the amount of energy required to raise the temperature of 100 grams of water from 25 degrees Celsius to 70 degrees Celsius. Well, what we have to do is we have to find the energy. That's delta Q. Then we plug in our mass, which is 100 grams. The substance that we're heating up is water, so we have to find the specific heat of water. So water has a specific heat of 4.184 joules per gram degree Celsius. So we're just going to plug that in, and we're going to get 4.184 joules per gram degree Celsius. Now we want to go from a 25 degrees Celsius temperature to a 70 degrees Celsius temperature. So our final temperature is 70 degrees minus our initial temperature of 25 degrees Celsius. Okay, so then we go ahead and we do the math. And the math tells us that we're going to acquire 18,828 joules. That's the amount of energy it takes to raise the temperature of 100 grams of water from 25 to 70 degrees Celsius. What if we were to start out at 70 degrees Celsius and cool the water down to 25? So what if we went from 70 degrees Celsius and we went to 25 degrees Celsius? Well, then what we'd have to do is we'd have to change our final temperature, which is 25 degrees Celsius, minus our initial temperature of 70 degrees Celsius. That would be our delta T. And so we'd have to replace this. Now we notice in the parentheses we're going to get a negative sign. Therefore, our energy is going to be negative. That means energy was removed. So we would have to remove 18,828 joules in order to go from 70 degrees Celsius down to 25 degrees Celsius. Now if we have a different material such as lead, gold, mercury, silver, then what we have to do is we have to make sure that we use the specific heat of that material, because every material has a different specific heat. All materials will transfer energy at different rates. Specific heat is the amount of energy it takes to raise the temperature of 1 gram of a material by 1 degree Celsius. Imagine going to your favorite pizza restaurant, and you go in and you order your pizza, they bring it to the table. It just came out of this really hot oven. As soon as you take a bite, that sauce burns your tongue. But if you bit into the crust, your tongue doesn't get burned. Why is that? It's because of specific heat. The crust will transfer energy at a different rate. The crust will lose energy at a much faster rate than the sauce. That's why the sauce still remains hot. Before you go ahead and do problems, what I'd like for you to do is I'd like for you to notice that we have our solid, liquid, and gas states for our specific heats. So what you should know is the specific heat of a material is dependent upon what state of matter that material is in. So I wanted you to be cautious about that. Make sure that you're in the correct state of matter to use that specific heat. So the specific heat of a material will change depending on what the temperature is. Okay, I think you're ready to try some of these examples on your own. So do your homework and then work on the quiz. Have a great day.